As the moon's core cools and shrinks, its surface develops creases that create moonquakes as well as landslides. A region of the moon that's at the center of a new international space race, because it may contain water ice, could be less hospitable than once thought, new research has found. Interest in the lunar South Pole spiked last year, when India's Chandrayaan-3 mission made the first successful soft landing in the area, just days after Russia's Luna 25 spacecraft crashed en route to attempt the same feat. NASA has selected the region as the landing site for its Artemis III mission, which could mark the return of astronauts to the moon as soon as 2026, and China also has plans to create future habitats there. But now a study funded by NASA is ringing an alarm bell. As the moon's core gradually cools and shrinks, its surface develops creases like a grape shriveling into a raisin that create moonquakes that can last for hours, as well as landslides. Much like the rest of the natural satellite surface, the area of the South Pole, that is the subject of so much interest, is prone to these seismic phenomena, potentially posing a threat to future human settlers and equipment. This is not to alarm anyone, and certainly not to discourage exploration of that part of the South Pole of the moon, said the study's lead author, Thomas R. Waters, a senior scientist emeritus in the National Air and Space Museum Center for Earth and Planetary Studies, but to raise the caution that the moon is not this benign place where nothing is happening. The moon has shrunk by about 150 feet in circumference over the last few million years, a significant number in geological terms, but too small to cause any ripple effect on Earth or to tidal cycles, according to researchers. On the lunar surface, however, it's a different story. Despite what its appearance might suggest, the moon still has a hot interior, which makes it seismically active. There is an outer core that's molten and is cooling off, Waters said. As it cools, the moon shrinks, the interior volume changes, and the crust has to adjust to that change. It's a global contraction, to which tidal forces on the Earth also contribute. Because the moon's surface is brittle, this pulling generates cracks, which geologists call faults. The moon is thought of as being this geologically dead object, where nothing has happened for billions of years, but that couldn't be more far from the truth, Waters said. These faults are very young, and things are happening. We've actually detected landslides that have occurred during the time that the Lunar Reconnaissance Orbiter has been in orbit around the moon. NASA's Lunar Reconnaissance Orbiter, or LRO, launched in 2009, and it's mapping the moon's surface with various instruments. In the new study, published January 25 in the Planetary Science Journal, Waters and his colleagues used data collected by LRO to link a powerful moonquake, detected with instruments left by Apollo astronauts more than 50 years ago, to a series of faults in the lunar South Pole. We knew from the Apollo seismic experiment, which were 4 seismometers that operated for a period of about 7 years, that there were these shallow moonquakes, but we didn't really know what the source was, Waters added. We also knew that the largest of the shallow moonquakes detected by the Apollo seismometers was located near the South Pole. It kind of became a sort of a detective story to try to figure out what the source was, and it turns out that these young faults are the best suspect. The strongest recorded quake was the equivalent of magnitude 5.0. On Earth, that would be considered moderate, but the moon's lower gravity would make it feel worse, Waters said. On the Earth, you have a much stronger gravity keeping you attached to the surface. On the moon, it's much smaller, so even a little bit of ground acceleration is going to potentially pop you off your feet if you're walking along, he said. That kind of shaking can really start throwing things around in a low-G environment. The findings of the study will not affect the Artemis III landing region selection process, and that's due to the scope and duration of the mission, according to study co-author and NASA planetary scientist Renee Weber. This is because estimating how often a specific region experiences a moonquake is difficult to do accurately, and like earthquakes, we can't predict moonquakes, Weber said. Strong shallow moonquakes are infrequent and pose a low risk to short-term missions on the lunar surface. Let's pause for a few seconds and give me a like for this video. Thank you so much. NASA has identified 13 Artemis III candidate landing regions near the lunar South Pole. She added, using criteria such as the ability to land safely in the region, the potential to meet science objectives, launch window availability, and conditions such as terrain, communications, and lighting. As part of the mission, 2 astronauts will spend about a week living and working on the lunar surface. However, Weber said, for a long-term human presence on the moon, the site selection process could indeed factor in geographic characteristics, such as proximity to tectonic features and terrain. Moonquakes could indeed be a problem for future manned landing missions. Yoshio Nakamura, a professor emeritus of geophysics at the University of Texas at Austin, who was among the researchers who first looked at the data collected by the Apollo seismic stations. However, Nakamura, who was not involved with the study, disagrees about the cause of the quakes, and said Apollo data shows the phenomena originate tens of kilometers below the surface. We still don't know what causes shallow moonquakes, but it is not the sliding fault near the surface, he said. Regardless of what causes those quakes, it is true that they pose a potential threat to future landing missions, and we need more data about them. Regardless of the underlying cause, the potential danger moonquakes pose to astronauts will be limited by the fact that, at least in the near future, humans will be on the moon for short periods of time, a few days at most, according to Alan Husker, a research professor of geophysics at the California Institute of Technology, who is also not involved with the study. It is very unlikely that a large moonquake will happen while they are there. However, it is good to know that these seismic sources causing the quakes exist. They can be an opportunity to better study the moon, as we do on the Earth with earthquakes, Husker said. By the time there is an actual moon base, we should have a much better idea of the actual seismic hazard with upcoming missions. That sentiment is shared by Jeffrey Andrews Hanna, an associate professor of planetary science at the University of Arizona, who also didn't participate in the work. Moonquakes are an incredible tool for doing science, he said in an email. They are like flashlights in the lunar interior that illuminate its structure for us to see. Studying moonquakes at the South Pole will tell us more about the moon's interior structure, as well as its present-day activity. As we peer deeper into the moon's enigmatic heart, these moonquakes aren't mere tremors, they're whispers from a living world, urging us to listen and learn. Imagine standing on that ancient, silvered surface, feeling the subtle shudders beneath your boots, a reminder that the moon, far from a lifeless relic, pulses with geological vitality. Recent reanalyses of Apollo-era data have unveiled a staggering 22,000 previously undetected moonquakes, tripling our catalog and painting a picture of a far more seismically active satellite than we ever dreamed. This revelation, coupled with India's Chandrayaan-3 mission, detecting over 50 mysterious seismic events near the South Pole in 2024, ignites a profound sense of wonder. Our celestial companion is alive, contracting like a beating heart, its faults cracking open secrets buried for eons. Yet, with this excitement comes a sobering call to caution. A July 2025 study highlights how these quakes, some magnitude 3.0 or stronger, have reshaped landscapes like the Taurus Littrow Valley over the past 90 million years, toppling boulders and triggering landslides that could endanger future habitats. For NASA's Artemis III, slated for 2026, the risks remain low for brief visits, perhaps 1 in millions daily near active faults, but they escalate dramatically for permanent outposts, where a decade-long stay amplifies the odds to 1 in 5,500. Tall landers like SpaceX's Starship, with their narrow bases, might wobble perilously in a strong shake. Yet this very vulnerability drives innovation. Wider footprints, seismic dampers, and strategic site selection away from scarps. NASA's response? Bold and brilliant, the Farside Seismic Suite, launching in 2026 to Schrödinger Basin near the South Pole. We'll deploy ultra-sensitive seismometers, 30 times more precise than Apollo's, to map these quakes in unprecedented detail. Drawing from Mars' InSight mission, it illuminates the Moon's molten core and far-side mysteries, transforming hazards into gateways of discovery. Meanwhile, a January 2025 survey of small mare ridges reveals ongoing tectonic shifts in the southern hemisphere, some as young as 110 million years, underscoring the South Pole's dynamic terrain. Dear explorers, let's not shy from these quakes. Embrace them. They challenge us to engineer resilient lunar homes, harvest water ice for sustenance, and forge humanity's next chapter among the stars. The Moon beckons not with peril alone, but with promise, a frozen archive of solar system history, a stepping stone to Mars, a beacon for our unquenchable curiosity. As we prepare for Artemis and beyond, remember, in the face of cosmic forces, our ingenuity shines brightest. The South Pole's ice may hide beneath unstable ground, but atop it, we'll build dreams that endure.